Very good evening all and very warm welcome to the session. So happy to meet you all back in this awesome session. Yes, so today we are going to learn about protein synthesis. So protein synthesis as such is a very important subtopic for your preparation. As a part of rapid revision, we will be learning a lot on protein synthesis. Yes everybody, so I hope that you are all ready to prepare well for this protein synthesis unit. Okay. Right, so this month we are beginning with the very first lesson. It is on protein synthesis, right? So this is little bit about me. I am Dr. Saranya. So I have already cracked our CSIR NET along with the TN set, and I have 15 papers to my credit. I have already completed my Ph.D in Biomaterials. Okay, so this is my profile and I am teaching here for the past 10 years and with Unacademy and associated with greater than 3+ years. Okay, so this is about the iconic as well as the plus subscription. If at all you are not still aware of what is this iconic and what is going to be this plus subscription, please keep informed that plus subscription will include your live classes, weekly tests, structured courses and unlimited access to the recorded version apart from live. And iconic will have added advantage of test analysis. They will give you a planner and they will have a guided performance, right? So that is about this iconic subscription. So I think this is all is clear. So let's begin up with today's session, and this is about the free special classes. So if at all you have not yet tried with this special class, you can use my code Saranya Live and attend them all for free in this Unacademy app. Okay. So today we are going to learn about protein synthesis. The official name of protein synthesis, it is what is called as translation. So what do you mean by translation? Translation, it is going to be the process of conversion of your mRNA into a polypeptide. The polypeptide is nothing but it is going to be a protein. So if I have a codon, where will be the codon present? Codon is present within my mRNA. That is going to undergo the process of translation. Okay. So once it is going to undergo the translation, it is going to go for the production of your amino acids. These amino acids are linked by the peptide bond. So when amino acids are linked by the peptide bond, how do you call them as? You call them as a protein. Okay, so the polypeptides, they will be making up your protein. Okay, so how a protein is being made? The protein is made up of small amino acids, and all these amino acids are linked by means of this peptide bond. So that is what is going to make up your protein, and the protein is made from your mRNA. This mRNA is going to serve as a template. Okay, so 3 of the bases, it is going to form the codon. So 3 of the bases forming the codon. Each codon is going to specify one amino acid. So this process is what is made by means of this translation. So if at all I have to do my protein synthesis, it will have certain requirements. So what and all it is required for my protein synthesis? What are the things that is absolutely essential for any process that is involving my protein synthesis? Number 1, I need my mRNA. So mRNA is only going to supply my codons. Okay. Number 2, I will require my rRNA. What this rRNA will give? rRNA is only going to give away my ribosomes. Okay. The third fellow is my tRNA. The tRNA, it is going to provide with the anticodon. Remember, to this anticodon, one more fellow is attached. Who is that? It is going to be my amino acid. So all the things are required. So what things are required? You require an mRNA, you require your rRNA, you require your tRNA, and then you require the amino acids. So all these things are absolutely essential. Okay, right. Apart from this stuff, what else is required for you? You are going to require the enzymes. Can you guess any enzyme that you know for protein synthesis? Yes? Can you just state me few enzymes that is required for the protein synthesis? Amino acyl, tRNA, synthetase. Okay, peptidyl transferase. So many enzymes are involved, no? Peptidyl transferase, translocase. Yeah, that's so many, isn't it? So translocase is there, peptidyl transferase is there, amino acyl tRNA synthetase is there. All of them are the enzymes that are required for protein synthesis. Okay. Apart from that, what else you require? You have mRNA, you have the substrate, you have your enzymes. You require the factors. What are the factors? You will be requiring with the initiation factor, elongation factor, releasing factor. And then you will require the cofactor also. Okay, what are the cofactor? ATP, GTP, Mg2 plus. So what are the cofactor? ATP, GTP, Mg2 plus. So shall we repeat? Protein synthesis. What are the requirements of your protein synthesis? The requirement of protein synthesis, it is going to include your mRNA. Yes, it is only going to provide you with the codon. Second one, it is going to be the tRNA. It is only going to provide you with the anticodon. Number 3, it is going to be your rRNA. That is what it is going to give away your ribosomes. Apart from that, you require the amino acid that is only acting as a substrate. Right. Then what else you require? Amino acid as a substrate, you require the factors, you require the enzymes. Enzymes are like amino acyl tRNA synthetase, you require the translocase, you require the peptidyl transferase, all these enzymes are required. Apart from that, what else you will be requiring? Initiation factor, elongation factor, release factor or termination factor. Then you require ATP, you require GTP, Mg2 plus. So all these steps are required for your protein synthesis. Is it clear to everybody in the class? What does your protein synthesis require? No more doubts in this? Yes? Okay, fantastic. So many factors are required. Fine. So first we will see about your mRNA. Right. So what this mRNA is actually doing? This mRNA, it is only going to serve as a template. Okay. Right. So this mRNA is only going to serve as a template for your protein synthesis. it is going to be polycistronic in nature. Why? Okay, it is going to be polycistronic in nature. Okay, right, yes. So in case of eukaryote, it is going to be monocistron. Eukaryote, they follow one gene, one enzyme concept. Okay, but in case of prokaryote only, it is going to be polycistronic in nature. Okay, right. And the next important keyword that everybody should be aware is what is called as the genetic codon. Genetic codon means each of the codes of your mRNA, it is going to represent one of your amino acid. So that is what is represented by the genetic codon. Okay, alright. So few codons you have to definitely learn. One, it is going to be the start as well as the stop codon in general. The start codon is called as AUG. Okay. So this AUG, it is what is called as the start codon. Okay, so this AUG, it is what is called as the start codon. It is going to code for methionine also. AUG, it is going to code for methionine also. It is going to be the start codon. And what are the stop codons? Stop codons are going to include your UAA, UAG and UGA. There are three stop codons. What are they? UAA, UAG and UGA. There are going to be three stop codons. UAA, UAG, UGA. Three stop codons are there. And apart from that, other 61 codons are there for 20 amino acids. Okay, so got the point? Fine. So you have to remember all at least the start and the stop codons. Okay, fine. All the codons are universal. Yes, universal means it should be the same, right? But there are going to be few exemptions. Okay, so everything, it is not always the same. It is going to have a few exemption, right? Fine. So let us see what is making them to be exempted, right? So the best one, it says that if you take this cytoplasm, okay, AUA is the codon that is actually coding for isoleucine. This is normal. You can check AUA. Yes, AUA is coding for which amino acid? AUA, it is coding for isoleucine. So this is with your normal cytoplasm. But the same AUA, it is going to code for methionine. Usually what is coding for methionine? AUG. But in mitochondria, apart from AUG, AUA is also coding for methionine. Okay, so two codons for methionine. It is going to be your AUA as well as the AUG. Both of them, they code for methionine. Right? And what are the stop codons we saw? UAA, UAG, UGA. Three stop codons we saw. Yes or no? Everybody, are you alert? Yes? Right. But you see that in case of mitochondria, this UGA is there, no? This UGA, instead of being a stop codon, it codes for tryptophan. What about UAA and UAG? They are the termination codon. Okay, so UAA, UAG are termination codon, but this UGA alone codes for tryptophan. Right. And there are few addition termination codons here. It is going to be AGA and AGG. Okay, so start codon is AUA, stop codon, it is going to be UAA, UAG and then AGA and then AGG. Okay, so 4 stop codons and 1 start codon, two start codon for your mitochondria. This is the start codon and this is going to be the stop codon. Absolutely, it is very, very essential. Questions every time, many chances are there that these questions will be coming up. Always the exemptions, no? It is much asked in your examination. So you should be very, very careful with these exemptions. Got it? Yes, everybody in this class. So is it all clear to you like how it works? Okay, fantastic everybody. So let us see. It is going to be in the cytoplasm. AUA is coding for isoleucine. The same in mitochondria, the AUA is serving as a start codon along with your AUG. And then in cytoplasm, the stop codon, it is going to be UAA, UAG and UGA. But here the stop codon is going to be UGA is coding for tryptophan. UGA is coding for tryptophan, and then AGA and AGG, it is also additionally coding for the stop codon. So now you got the exemptions, right? The next important term that you have to learn here, it is called as Wobble base pair. And what is this called? Universal codon. It is called as codon degeneracy. That means more than one codon. More than one codon, it is going to specify your amino acid. More than one codon, it is going to specify your amino acid. If I say arginine, all these they specify arginine. So this is what is called as codon degeneracy. This is what is called as universal codon. This is an exemption for the universal codon. Now we are seeing what is this Wobble base pairing. Okay, right. So what happens with this Wobble base pairing, we will see. Wobble base pairing means it is going to be some kind of different in the base pairing. Normally, if I have a A residue, A will base pair with whom? With T. What this G will base pair? With C. And then now this is going to have some additional kind of changes. Okay, so I'm going to have few additional things such that my A can base pair with U also. This is all normal. Okay, so this is all normal. AU instead of T, it can pair. But if my G is pairing with U, can you call it as normal? Not at all. G is base pairing with U. Likewise, I is going to base pair with A also, with your, so I is called as inosine. Inosine can base pair with A also. Inosine can base pair with C also. Inosine can base pair with U also. Right? But inosine can never base pair with G, because inosine is an equivalent of G. Okay, inosine is equal to G. So whatever segments G is base pairing with, G is base pairing with C, G is base pairing with U, it can do, but G can never base pair with G. That is why I is never base pairing with G, but it can base pair with ACU. So G can base pair with U. These two are important Wobble base pairing. This is going to explain us something. Okay, I told you that there is a total of 64 codons. So among them there are 3 stop codons. So functionally you have 61 codons, right? So how many amino acids you have? 20 amino acids. How many tRNA you have? You have only 40 tRNA. How many tRNA you have? You have only 40 tRNA. Since because you have just 40 tRNA, is it possible for you to patch up with this codons? See, 40 tRNA, it is very less. You have to bind with 61 codons. So if you make your normal pairing, is it possible? Definitely not, no. I told you that for every mRNA, it has to base pair with your tRNA. So this is the codon, this is the anticodon. So if there is going to be 60 anticodon, no issues could have developed to us. But now there is going to be a very big issue. It is not at all possible for us. Right? So how we are going to solve this problem? How we are going to solve this problem? We are going to make use of this phenomenon of Wobble base pairing. So the first 2 things we are leaving. Okay, it will be based on general. but the third pair is there, no. Third of the codon and first of the anticodon, it is going to pair based on Wobble base pairing. This Wobble base pairing is going to be nothing but, yes, Tasneen. No, this is not a PYQ, Tasneen. This is a revision series. We are seeing few important components. Okay, so we are teaching up with the concepts. Okay, so today we are learning about the protein synthesis. PYQs we will be doing it in the next session. Yes, Tasneen, it is a rapid revision series we are doing. Got it, Tasneen? Okay, nice. Okay, so next class we will do revision, PYQs. Okay, nice. Alright, so is this clear now why we had, yes, yeah, Tasneen, that's great, fine, okay, fantastic. So now you got what is going to be the Wobble's base pair, and you know that the Wobble's base pair is G with U and I with ACU. This is all going to be the abnormal, or you call them as a non-Watson and Crick base pairing. So they are called as non-Watson and Crick base pairing. Got the point? Yes, everybody. So this non-Watson and Crick base pairing, this is what is absolutely very, very essential. Understood? So this is all clear to you? Okay. And this is how the structure of your tRNA looks like. So this has at a 3' OH end, you have something called as your CCA region. Why the CCA region is always a hype? Because to this region only your amino acid is attached. So to the CCA region, what is attached? Your amino acid is going to be attached. So this is what is called as amino acid activation. So tRNA is going to contain your anticodon. To that, who is attached? Your amino acid is attached. Understood? Right? So to activate this, you need an enzyme. Initially the tRNA will be empty. Correct. Initially the tRNA is going to be empty. Then the respective amino acid will be attached to it. So which enzyme is doing that? It is going to be tRNA, aminoacyl tRNA synthetase. What is the enzyme? Aminoacyl tRNA synthetase. So what is the enzyme called as? Aminoacyl tRNA synthetase. So what this aminoacyl tRNA synthetase enzyme will be doing? It is going to attach the amino acid. Okay, imagine that my tRNA, it is going to code for glutamine. Okay, right. I am getting a lysine. Okay, fine. So my amino acid is going to be lysine. Okay, and my tRNA is anticodon for glutamine. Can this attach now? Can this lysine amino acid be attached to the tRNA that is going to be of glutamine nature? Is it possible? No. Why it is not possible? Because this aminoacyl tRNA synthetase, it has a editing pocket and a catalytic pocket. So what it will do is that it will make exact lock and key type of fixation. So it will allow only if the same amino acid is coming inside. If some other thing is coming inside, it is not at all allowing them to go through. So it will be removed off. Either it will be chopped or it is not going to get attached. So it is highly specific. Why? Because it has an editing pocket, it has a catalytic pocket. So if it is going to be the same amino acid residue, if it is going to be lysine tRNA, lysine is coming, then it is going to get attached. Yes. No, Tasneen, I am from Tamil Nadu. So this is what is called as amino acid activation. Got the point? Yes? Okay. So during this activation, you need an energy. So what is the energy molecule? It is going to be ATP. So this ATP, it is going to be the energy molecule. So using this ATP energy only, your amino acid is getting attached to that of your tRNA. Got the point? So now you understood this. Then it becomes your aminoacylated tRNA. If alanine is coming, yes. Oh, very nice, Tasneen. Very happy to know. Yes. Oh, very nice, very nice. So this is going to be the alanine tRNA. Serine tRNA. So that means that this tRNA is going to attach with a particular amino acid. If it is other amino acid, it is going to get edited. It is going to get removed. So this is a very, very important process. So here your amino acyl tRNA, it is going to get formed. For this only you require all these enzymes activity. Okay, so this amino acyl tRNA synthetase, it has a proofreading ability because it is going to check whether the correct amino acid is getting attached. If it is an incorrect amino acid, it is cleaving the ester bond. It is not at all allowing. It is going to chop. It is going to chop and cleave the ester bond, and so it is not at all allowing them to take place. Got it? So that is the thing this amino acyl tRNA synthetase is doing. Okay, right. So shall we just try this question? Everybody in this class, we have read about the tRNA and the structure little bit. Yes, do you remember this tRNA structure? I think even today we saw this. Yeah. So this is the basic structure of your tRNA, isn't it? So it is going to contain a 3' end, a 5' end. It is going to contain a D arm, D C arm, anticodon arm and all. So shall we try this question up? Everybody in this class? Come on. So who is the acceptor arm? Acceptor arm, is it going to be your dihydrouridine? It is going to be your CCA, or it is going to be your 5 base pair stem? Is it going to be your pseudouridine? What is this acceptor arm? Yes, everybody in the class. Come on everyone, please let me please type it. What is going to be the acceptor arm? Is it dihydrouridine? Is it a 7 base pair stem and CCA sequence? Very good, Testin. Come on. And then what is T-C arm? What is D arm? Okay. So D arm, by name only it tells it is going to be the dihydrouridine. Okay. So this is going to be your dihydrouridine. T-C arm is the pseudouridine. Right. Anticodon arm. Where is this anticodon arm present? Think and tell me. Where is this anticodon arm present? Anticodon arm is in the 5 base pair stem. And this acceptor arm is only going to be your CCA. Got it everybody? Right. So which answer is right? Your answer D is only going to be the right answer. Got it everybody? So what is the acceptor arm? What is the anticodon arm? And what is the T-C arm? It is all clear? Yes everyone. So got it now? So no more doubts on this? Yes. Correct, Astin. That's okay. Nothing wrong in committing a mistake. We are here to learn only. Isn't it? Okay, cool everyone. So let us see the next question. Today did we learn this or not? I told you about the mitochondria. So the mitochondria, how it is different from the cytoplasm. In cytoplasm, I told you that AUG is the start codon. But in mitochondria, we have seen one more start codon. Right. And what happened to the stop codon also we studied today. If you remember that, this will become simple and easy. Think everybody. Think about this and answer. It will be so much simple for you all. Yes, everybody. So, AUG, AUA, CUG, UGA. If it is a cytosol, how many amino acids will be synthesized? How long will be the peptide? Think. And if it is going to be the mitochondria, how long it is going to be synthesized? In cytoplasm, AUG is the start codon. What are the stop codons? UGA, UAG, then, come on everybody, UGA, UAG, One more stop codon. 3 stop codons you saw, no? UGA is the stop codon. UAG is the stop codon. And then one more stop codon. Come on everybody, think over. So this is in cytoplasm. Likewise, I taught you for your I taught you for your mitochondria also, isn't it? Yes. Okay. UAA. These three are for your cytoplasm. So for mitochondria, what are the stop codon? UGA alone will not come, isn't it? So UAG, UAA, and then AGG, AGA, right? So these many were there for the mitochondria. So think and write. Then it will become simple for you now. So for your cytoplasm, here is your start codon. So only 3 residues will be there for cytosol. Methionine, isoleucine, leucine. Because this is very big, no? So this cannot come for your cytoplasm. This is wrong. For mitochondria, AGG is the stop codon. So till this it can be. So there is going to be 2 methionine. AUG is also methionine. AUA is also methionine. Right? And then leucine, tryptophan and leucine. Right? So for A, it is going to be, for cytosol it is going to be A. And for mitochondria it is going to be 2. So your B is going to be the correct answer for this question. Got it everybody? Yes? So remember this table. Frequently I am telling you. This table is very, very important. Yes everybody? So now you got it? So absolutely this is very, very important for your examination. Don't ever try to skip this question. Alright. Fine. Yes everybody. So this is what is absolutely essential. Don't miss this key points. Okay. So when you do the PYQs and MCQs only you will know like which is important and which is the thing that you have to focus. Okay. So the direction of synthesis of your protein. Okay. So protein synthesis direction, it is also from your 5' to 3'. Got the point? So your mRNA is also 5' to 3', and then your DNA is, direction is 5' to 3', but it will be synthesizing 2 strands. Yes, your leading and lagging strand, but still it is going to be the thing. Okay, so now this is going to be your protein synthesis is going to take place in N terminus to C terminus. Okay, so it is going to be synthesized in the N terminus to the C terminus. Right. And the next one is that the process of protein synthesis, it includes your initiation, elongation, as well as the termination. So 3 things are there. What are they? Initiation, elongation and termination. Is the initiation same in both your prokaryotes and eukaryotes? Not at all. In prokaryotes, you have this formyl methionine. Okay, right. So this formyl methionine is only for the prokaryotes. But in case of the eukaryotes, you have the ordinary methionine. Okay. So in case of prokaryote, you have an additional formyl. The formyl group is an additional in your prokaryote alone. But in your eukaryote, let it be your initiation, let it be your elongation, it is only going to have your methionine. Okay, right, it is not having any formyl methionine. So if you take the ribosomes, in case of the prokaryotic, you have the, what, yes, it is going to be, come on, in prokaryote, how many yes you have? Quick, quick. In prokaryotes, what yes is there? Very quick. 50 and 30. Here it is 60 and 40. In eukaryote, what is the total sum? Yes? 50s is larger subunit, 30s is smaller subunit. But in total, this is against mathematics. Yes? Why? Because we measure only the density. Yeah, we measure only the density. So this becomes 70s, this becomes your 80s. Okay, you don't call it as 80 and 100, rather you call it as 70 and 80. Okay, so there is a larger subunit and a smaller subunit. Okay, yes, absolutely. So prokaryotes, it will have 50-30, eukaryotes, it will have 60-40. This is for absolutely essential. So there are three sites. What is the three site? This is going to be your mRNA. So this is going to have your 5' to 3' region. Okay, so this mRNA, it is going to be from the 5' to 3' region. So it has few sites. It is called as E, P, A. E, it is what is called as the exit site. P, it is called as the peptidyl site. A, it is called as amino acyl site. Okay, so amino acyl site means it is where your amino acid is coming inside. How your amino acid will come inside? Your amino acid will come inside by means of this tRNA. So this tRNA, it is only going to bring inside my amino acid. Okay, so this is what is called as the A site. So next site, there is a peptide bond formation now. So it is called as peptidyl site. Now once the peptide site is formed, and no, E is not entry, E is going to be the exit. Empty tRNA is there, no, it is going to be sent out. So this empty tRNA is only exiting through the exit site. This is going to be your ribosome. Okay, this is only going to be the ribosome. This is how your ribosome is moving. It is moving in 5' to 3' direction. Okay, so whenever, yes, that's okay, Tasnin. So nice of you. Okay, so this is how it is all moving. Okay, so it is going to be the exit, peptidyl and amino. Now when it is moving in this direction, this P site is going to become an E site. This A site will become a P site. This new site will become a site. So this is where the entry is going to take place. This is where a peptide bond is going to take place. This is where the exit is going to take place. So in the next round, it will go in this direction. So this will become E, this will become P, this will become A. So now everybody in this class got it. What is going to be this E site, P site and A site? Yes, everybody, no more confusion in this. Okay, so A site, it is what is called as amino acyl site. So this is made up of both the larger and the smaller subunit. So this is the site where it is going to accept your incoming amino acyl tRNA. Second site is called as the P site. So this P site is also composed of your larger and smaller subunit. This is only forming the peptidyl bonds. Next, E site is the exit site. It is made up of only the large subunit. Smaller subunit, it is not at all having this exit site. It is present only in the large site. So this will release the deacylated tRNA. It is the exit of the tRNA. Got it? So for all of you, is this clear about your EPA site? Yes, everybody. So EPA site is absolutely clear, everybody in this class. So no more doubts, I guess, regarding this one. Yes? Okay, fantastic. So this is what you have to know about your ribosomes. Okay, so these are the different sites. So let us see in detail about the prokaryotic initiation. You tell me whether the prokaryotic initiation is requiring formyl methionine or ordinary methionine in case of your prokaryote. In case of prokaryote, they use your formyl methionine or ordinary methionine. They are going to use your formyl methionine. Okay. Yes, so it is going to use your formyl methionine. Okay, so let us see the steps that is involved in the initiation. So there are 4 major steps. Number 1, there should be the separation between the 50S and 30S ribosomal subunit. So this is the large, this is the small. So 50S and 30S ribosomal subunit, it should be separated. Second step, after separation, this 30S is there, no? This 30S. So over this 30S, your mRNA is placed. Did you guess which mRNA codon will bind to the first 30S? Any guess? Which mRNA codon will bind to the first 30S subunit? It is going to be your AUG, isn't it? Because that is going to be your start codon. Okay, right. So first step, it is the separation between 50S and 30S. The second step, it is going to be the binding of your mRNA with the 30S subunit. Fine. The third one, it is going to be the entry. This is where there is a small twist. I told you that all the entry will be made at the A site. Correct? Always in biology, if you say something, one exemption will be there. So what is the exemption? The exemption is that for the first residue alone, where is the entry? The entry is going to be at the P site. For the first residue alone, the entry is taking place directly at the P site. Okay, usually it should be A and then P, no. But for the first alone, directly it is entering into the P site. Because there is no point in forming a peptide bond with 0, no. So that is why it is moving on to the P site. But remember, this works only for your first time. Later and all the entry will take place through A only. Okay, so that is what is an important step. Registering your formal methionine tRNA on the P site. Okay, right. And the fourth one, now it is the association of the 50S subunit. Okay, so now we will just make up all these initiation steps in a separate manner. In a separate page on the initiation. Number 1, there is going to be the dissociation. So usually your ribosomes will be assembled, no. So this 50S and 30S ribosomal subunit, it should be dissociated. So once it is dissociated, that is what is going to be the very first step. Second one, it is going to be the positioning. Positioning of what? It is going to be the positioning of your mRNA. So where your mRNA is positioned? It is positioned on your ribosome. Which part of the ribosome? 30S part of the ribosome. Okay. Third one, it is going to add your formal methionine tRNA to which site? To that of your P site. Yeah, it is added directly to the P site. Right. And then what is the fourth one? It is going to be the association of larger subunit. So which one is associated? Larger subunit is now associated. So these are the 4 important steps. Apart from that, you see that the initiation factors IF1, 2, 3 are involved. What is the role of IF1, 2, 3 now? This IF1 and 3, it is only facilitating the separation. I told you this 4 step, no, separation of 50S and 30S. This is only facilitated. This is only facilitated by whom? IF1 and IF3. So IF1 and IF3, it is only going to facilitate the separation between your 50S and 30S subunits. This is clear, right? Okay. So second one I told you, it is the positioning of the 30S on your mRNA. So that is what is taking the second step. Okay. So how this binding is initiated? How correctly it comes and bind with your start site. Somebody should be helping in this. So it is going to be in case of prokaryote. So who is this ribosome binding sequence? In prokaryote it is called as Shine-Dalgarno sequence. What is the sequence called? Shine-Dalgarno sequence. And in case of the eukaryote, you call them as the Kozak sequence. In eukaryote, what it is called as? It is called as Kozak sequence. In prokaryotes, you call them as the Shine-Dalgarno sequence. In eukaryote, you call them as the Kozak sequence. So this is clear to you what is going to be the Shine-Dalgarno sequence and what is going to be the Kozak sequence. They are nothing but it is the ribosomal binding site where these are located within your mRNA. Okay, so to this region only your ribosome is binding. So that is what is called as ribosomal binding sites. So the initiation, it happens by the special sequence of mRNA. It is only called as the ribosomal binding site. Okay, so what it is called as? It is called as the ribosomal binding site. So to this site only it is called as your Shine-Dalgarno sequence. To this site only your ribosomes are going to be binding. Got it? Yes. After they bind only all other things will take place. Next one, when your F methionine is coming inside, no, that time one more initiation factor, IF2 is coming. This IF2, it is always associated with the GTP. So what this IF2 is associated with? This IF2 is associated with the GTP. It is going to function as GTPase, okay. So it is going to give you the energy, right. So that is what is going to be the function of this guy. Alright, so when your IF1 and 3 is helping, IF1 and 3 it is helping in the separation of your large and small subunit. Okay, so it is going to lead to the separation of the large and small subunit. And what this IF2 is doing, it is doing in the entry of methionine tRNA. So methionine tRNA is to enter inside, no. For that this fellow is going to help. Where it is entering into the P site. Okay, and in the fourth step, when your big subunit is coming and associating, this GTP, it is hydrolyzed. So once it is hydrolyzed, energy came, no? Energy coming means somebody will be sent out. Who is sent out? All your, so who is being sent out? All your IF1, IF2, IF3. So all these three things are now going to be sent out. Okay, right. So IF1, IF2, IF3. All these three things it is sent out. Okay, right. So that is what it is happening with this thing. Okay, so that is going to be the association of your 50S subunit. So once your 50S subunit it is going to be associated, right? So now what happens? It is going to so what happens? It is going to kick out all these factors outside. So is this all clear to you? So did you get it now, everybody in this class? Is it all clear, like what things are going up? All right, fantastic everybody. I hope that this is pretty clear to you now. Okay, so during the initiation, one GTP it is going to be consumed. So during this reaction, one GTP it is consumed as the initiation. Okay, so shall we summarize the initiation? So during the initiation, number one, there is going to be the separation of your 50S as well as 30S subunit. So this is what it is done by your IF1 as well as IF3. Number two, there is going to be the positioning of your mRNA. So where your mRNA is positioned? To the 30S subunit. So who is helping in this positioning? It is going to be the Shine-Dalgarno sequence, right? And the third one, so and what is going to be the third one? The third one, that is going to be the come on everyone, association of your larger subunit. Okay, so binding, and your formyl methionine is going to bind to your T site. So who is favoring that? Your IF2 is favoring that. And what is the fourth step? Yes. So the fourth step, it is going to make up with your so what is the fourth step? It is going to be the utilization of GTP. So GTPase is going to function. It is going to use your GTP. Once the GTP is utilized, it is going to kick out all your IF1, IF2 and IF3. So now the total binding is done, and this is what is initiation. Yes, so this is what is initiation. So by this the initiation is over. Got it? So what is the next step? It is going to be the elongation. So apart from all your Cossacks, yes, Bhagya Jyoti, yeah. So this is going to be the factor binding sites, right? So if you take the factor binding sites, it is going to have a definite location. Okay, so absolutely. So it is going to have a motif where all these sites are going to be binding. Exactly, Bhagya Jyoti. So your understanding is absolutely right. So these are going to bind at a particular site, and if you see this IF3, it binds at your 30th site, and your IF1, it is going to bind to your A site. Okay, so at a specific domain. Okay, so this is what is going to be the initiation. Okay, so after the initiation is done, it is going to prolong with your elongation. And apart from your Shine-Dalgarno sequence, that is what with your prokaryotes, and Cossack, it is going to be with your eukaryotes. You have one more region, that is what is called as IRES. It is the internal ribosomal entry site. So what these IRES will do, only two conditions it has an phenomenal performance. Number one, in case of virus like your hepatitis, in case of stress. So in these two things, they have a very, very important role. They will not wait to scan for your Cossack sequence. They will not wait to scan for your Shine-Dalgarno sequence. Rather, they have special sites. Okay, so these special sites are called as internal ribosomal entry sites. So they associate directly with the site. So they don't have to wait. They will bypass everything, and it is going to have a rapid jump. So that is what is called as IRES. Okay, right. So this is especially with the virus as well as the stress condition. Okay, right. And the next step, it is going to be the elongation. So elongation is nothing but it is mainly involving your peptide bond formation. So that is what is elongation. For that you require the elongation factors. Majorly it has 3 steps. Number 1, it is going to be the entrance. It is the second step, it is going to be the peptide bond formation, and the third step, it is going to be the translocation. Okay, yes, absolutely. Yes, Tasneen. See, it is this IRES. You can say that it is specific for your eukaryotes. Okay, because you are saying that there is going to be your 40th subunit. Okay, right. But there is in viruses also it is there. Okay, right. So usually it is for your eukaryote, but for viruses also it is going to be there. What the difference? Yes. Okay, fine. So so this one we'll see later. So the next one is the 3 steps that is involved in the elongation. So what are going to be the 3 steps that is involved in the elongation? It is going to be, yes, it is going to be the entrance, it is going to be the peptide bond formation, and it is going to be the translocation. So these 3 are the major steps that is involved in the elongation. Obviously, it is going to involve the enzymes like translocase, peptidyl transferase, for which your TUTS complex is involved. Okay, so today as the time is little bit less, I am just skipping this topic. Okay, so definitely in the next session we will be meeting back with little bit more information on this elongation and termination. Due to lack of time, I am just closing this session. Okay, definitely don't worry, in the next session or at least in the shorts, okay, I will put with your elongation process. Okay, so please do follow in shorts as well, such that you will complete this elongation. Okay, so in termination you have these 2 things. One, it is going to be release factor 1, 2, 3. So release factor 1 will recognize UAA and UAG. Release factor 2, it will recognize UAA and UGA. Okay, so it will recognize these two. And RF3, it is responsible for hydrolysis. Once the hydrolysis is done, it is going to terminate your peptide. So the peptide is going to get released. So the key enzyme is peptidyl esterase. So the esterase, it is going to be the key enzyme. That is what it is going to terminate. So initiation, elongation, termination. So these three are the key steps. That is what it is getting involved in your protein synthesis. I hope that this was all helpful for your preparation. Yes, everybody. So make a complete thing. And definitely I'll meet you back in another interesting session. If at all you have not yet subscribed, please do subscribe. Thanks for watching. All the very best everyone. Take care and bye-bye. Thank you all. Thanks a lot.